Let's solve problem 14 on the 2019 AIME 2. So the problem says, find the sum of all positive integers n such that given an unlimited supply of stamps of denominations 5, n, and n plus 1, 91 cents is the greatest postage that cannot be formed. Okay, so a formable postage is basically going to be of the form 5a plus nb plus n plus 1c, where a, b, and c are non-negative integers. So some of them can equal 0, and we can just, use only 5s, only n's, only n plus 1s, or we can use some combination of them. So they're unlimited, right? So we can have as many as we want. But 91 cents has to be the greatest unformable postage. So how do we really go about tackling this problem, right? A lot of you may know about the chicken Mcnugget theorem, but that only works for two denominations, right? It states that for denominations m and n, the largest unformable number is mn minus m plus n. But we can't really apply that here because we have more than two denominations. So we kind of have to think about maybe combining two of the denominations together and then doing casework on that. So how can we go about combining denominations? Well, what if we could do casework on what n could be relative to 5? So like if n was a multiple of 5, or if n is 1 mod 5, 2 mod 5, 3 mod 5, etc. So let's do casework on that, right? So let's start off with our first case. So let's say n is a multiple of 5, or n is congruent to 0 mod 5. If n is a multiple of 5, then the denominations just basically boil down to 5 and n plus 1. So then we can use the chicken McNugget theorem, right? So then we'll have 5 times n plus 1 minus n plus 6, and we want this to equal 91. So then we'll have 4n is equal to 92, which implies that n equals 23. So is 23 a valid value? Well, our whole case was based on the fact that n is a multiple of 5, and 23 isn't a multiple of 5. So this is invalid, right? And the chicken McNugget theorem returns invalid values if you have more than two denominations. So it's not really reliable here. So that's why it gave us this bad value. So no values for case 1. Now let's go on to case 2, where n is congruent to 1 mod 5. Okay, if n is congruent to 1 mod 5, then what can we say about n? Well, immediately we can notice that 91 is also congruent to 1 mod 5. So if n is less than 91, then this isn't going to work because we can add any amount of multiples of 5s to n to get to 91. So what do I mean by that, right? 66, for example, is also congruent to 1 mod 5. So if I continued adding multiples of 5 to 66, I would eventually get to 91, right? Because 66 plus 5 plus 20 is going to get me to 91. So it's not going to work if n is less than 91, because then I can use combinations of 5 and n to get myself to 91. So that means that n has to be greater than 91, if we even consider this case to work. So n has to be greater than 91, but n is still congruent to 1 mod 5. So this also isn't going to work, and the reason being is if we let n equal some number greater than 91, for example 96, which is congruent to 1 mod 5, then it says here 91 cents is the greatest postage that can't be formed. That's clearly false because our denominations would become 96, 97, and 5. And if you notice, 92 is also not formable, right? These are not formable. 92, 93, 94, 95. It's impossible to form these values because 96 is greater than all of these values. So, actually no, 95 is formable, my bad. But all these numbers here, 92, 93, 94, these are all not formable given only these denominations. It's impossible. So 91 cents is not the greatest postage that cannot be formed. 94 is greater than 91, so is 92 and 93. So this is also a clear contradiction. So there are no cases that work for when n is congruent to 1 mod 5. Okay, now let's do our third case, where n is congruent to 2 mod 5. Okay, so now things get a bit tricky because we can't do something really smart with the 0 and 1 mod 5's case, right? So now we have to kind of think about our other denominations, right? So let's look at n plus 1. Obviously, n plus 1 is just going to be 3 mod 5, right? So we have n plus 1 is congruent to 3 mod 5. Okay, and so also keep in mind that all these are the smallest formable numbers that are congruent to their respective mods. So n is the smallest formable number congruent to 2 mod 5, n plus 1 is the smallest formable number congruent to 3 mod 5, etc., right? So this is some very key information. So n plus 1 is the smallest formable number congruent to 3 mod 5. Okay, so is there anything else we can do? Well, we know that how can we get to this 1 mod 5, right? Because 91 is congruent to 1 mod 5. We really want to be dealing with that. So what we can do is we can basically, so we can take 2 times n plus 1, right? Because if we take 2 times n plus 1, then we'll get 2n plus 2, which is also congruent to 1 mod 5. Now, you may have noticed that I could have also taken n, and I could have multiplied that by 3. So I could have also gotten 3n, which is also congruent to 1 mod 5. Right? So which one? So let's... Basically, both of these are both congruent to the same mod, right? So if 2n plus 2 is the smallest formable number that's congruent to 1 mod 5, then that implies that 3n is going to be formable as well. And 3n is not necessarily the smallest formable number, because 2n plus 2 is smaller than 3n. So we don't really need to worry about 3n. Since it's larger than 2n plus 2, it's implied to be formed if 2n plus 2 is formed. So if 2n plus 2 is the smallest formable number that's congruent to 1 mod 5. Okay, so then what's the smallest unformed, or the largest unformable number, right? That's congruent to 1 mod 5. Well, the largest unformable number is just when we go 5 back from this. If we go 5 back from this, then we're just going to get 2n minus 3. And this is the largest unformable number congruent to 1 mod 5. Now, why did we go back 5? Well, if 2n plus 2 is the smallest formable number congruent to 1 mod 5, then that means 2n minus 3 was not formable. And so wasn't 2n minus 8, and etc. Because if it was, then we could just keep adding multiples of 5 to get here, and we would have a number smaller than that, which would be formable. So 2n minus 3 is the smallest unformable number congruent to 1 mod 5. So to help visualize this better, let's maybe draw a modular residue table. And that's just a fancy term for different remainders when we divide a number by 5. So we'll draw 4 columns. So we'll call these residues 1, 2, 3, 4, and 0, or 5. So these are our multiples of 5s. These are 1 residues, 2 residues, etc. Okay, so now for this whole case, right, this is based on n is congruent to 2 mod 5, right? So we'll have like 6, 7, 8, 9, 10, etc. So n is going to be somewhere here. N is the smallest formable number, which is congruent to 2 mod 5. So n plus 1 is the smallest number, which is smallest formable number, which is congruent to 3 mod 5. And we established 2n plus 2 is the smallest formable number, which is congruent to 1 mod 5. And then but the problem implies that all multiples of 5 are formable, so we don't need to worry about these. Now, what about the 4 mod 5s, right? Well, 2n is congruent to 2 mod 5, so 2n is going to be the smallest formable number congruent to 4 mod 5. Okay, so what we see here is that 2n plus 2 is the greatest out of all of these 4 smallest formable numbers, right? So if 2n plus 2 is the smallest formable number, which is congruent to 1 mod 5, then 2n minus 3 has to be the largest unformable number, which is congruent to 1 mod 5. And this is actually the largest unformable number out of all of them, because 2n minus 3 is greater than 2n minus 5, it's greater than n minus 4, and it's greater than n minus 5. So this could actually work, right? So if we we need to basically take 2n minus 3, and we just set this equal to 91, right? So this is going to work, because then we'll get n equals 47, and that just satisfies the problem's conditions, right? Because 2n minus 3 is 47, which is the largest unformable number that is congruent to 1 mod 5, and it's the largest unformable number overall in this whole set of n plus 1 and 5. So we found one value, which is n is equal to 47. Okay, so now let's go to the fourth case, where n is congruent to 3 mod 5. Okay, so n is congruent to 3 mod 5. Then that implies that n plus 1 is congruent to 4 mod 5. Right, so n plus 1 is the smallest formable number, which is congruent to 4 mod 5. What's the largest formable number, the smallest formable number, which is congruent to 1 mod 5? Well, that's 2n. 2n is the smallest formable number, congruent to 1 mod 5. So we so far have 1, 3, 4, and 0. So from the numbers 1 until 2n, right, all of the residues of 0, 1, 3, and 4 are formable. So what that means is that the residue of 2 is unformable here. So let's take the 2 mod 5 now, right? We need to find 2 mod 5 somewhere. So if we took n plus 1 and multiplied that by 3, then we would get 3n plus 3. And this is the smallest formable number, which is congruent to 2 mod 5. Okay, so now we have all the residues. We have 0, 1, 2, 3, and 4. So what's the largest unformable number? Well, the largest unformable number is 3n plus 3. The smallest formable number is congruent to 2 mod 5 is this, right? So the largest unformable number is just 3n minus 2, right? Because we're just subtracting 5 from this. And that's greater than the 1 mod 5 case, which is 2n minus 5. So this is not going to work, because 2 mod 5 is not congruent to 91. So this case is not going to give us any valid values. So now let's go to the final case, where n is congruent to 4 mod 5. Okay, if n is congruent to 4 mod 5, then that implies that n plus 1 is just a multiple of 5. And then we also have 2n is congruent to 3 mod 5. So 2n is the smallest formable number, which is congruent to 3 mod 5. Okay, so we have 0, 1, 3, and 4, right? So from the numbers 1 until 2n, let me draw that better. From 1 until 2n, we have formable residues here, right? So from 1 to 2n, the only unformable residues here are 1 and 2, because we have 0, 3, and 4 accounted for. So we're missing the residues of 1 and 2. So we can bring back the residue table to kind of visualize this a bit better. So, oops, okay. So we bring back the residue table. 1, 2, 3, 4, 5. N is the smallest formable number congruent to 4 mod 5. All multiples of 5 are formable, so this is just insignificant, basically. N is not congruent to 3 mod 5. 2n. 2n is congruent to 3. We have 2n, and then we have 3 minus 2n. Okay, yeah, so we're left with 1 and 2. So what's the smallest formable number congruent to 1? Well, we'll take this 4, so 4 and then 8, 12, so 16, right? So 4n. So 4n is going to be the smallest representable number congruent to 1 mod 5. So, and now what about 2 mod 5? 2 mod 5 is just going to be 3n, which is, right, 3n. So what that means is that the largest unformable number congruent to 1 mod 5 is 4n minus 5. And this is the largest, again, out of these 4 options, right? It's greater than 3n minus 5, 2n minus 5, and n minus 5. So 4n minus 5 is the greatest unformable number in this case. So we can just set this equal to 91, right? And then we'll get n equals 24. So 24 here is a valid value. And it's also, yeah, so this value works. So we basically covered all cases, right? So our final answer is just going to be the two values we found, which were 47 and 24. So the sum is just going to be equal to 71, which is the final answer for this problem.